Well, hello everybody. My name is Morten. I'm the CTO of Skypuzzler Advanced Air Mobility. We are a small startup from Copenhagen, Denmark, where we try to help scale the drone industry by creating a digital air traffic control manager. Currently, we've been funded by the EU, as you can see, in the Danish Innovation Fund, and we've also received an ATM award for shaping the future skies of tomorrow. That's a big, quick one here. So who are we? Well, generally, we're based in Denmark. We have air traffic controllers, we have computer scientists, which collaborate together to create this algorithm that can make sure that drones do not collide mid-air. The air traffic controllers bring in a lot of operational understanding, and the computer scientists bring in a lot of algorithm knowledge, a lot of know-how how to develop software in a safe, reliable way. And we believe that this combination of the operational, the understanding of the airspace, and the computer scientists who actually understand how to develop cool and efficient algorithms make sure that we can come out with a really, really exquisite product. So what is the challenge? Well, as you can see here, we believe there's an increasing demand for drones in the urban air mobility. And we see this coming up. We've seen, if some of you people saw Mana Drone talk earlier, we have drone deliveries, we have air taxis, we have search and rescues and issues like that going on in urban areas. And that means that at some point you're going to see a congestion happening. Today, traditional air traffic controllers cannot handle this amount of drones in the air, so that's why we're developing this digital control system. It means that even if you have competitors in the same airspace, if you, for example, have Mana Drones and Google Wings in the same airspace, our algorithm makes sure that they can do their deliveries, but the drones will not collide mid-air, and we think that's a very important point to make in this moving forward the drone industry of especially the EU. So our solution, as I told you, is a digital air traffic controller. We believe that doing this here, safety is also a huge importance. If we're talking about having stuff flying in the air over people, we don't want to see them crashing down into little children, for example. So for us, safety is our first concern. We make sure that what we develop is actually inspectable and easy to understand for people to see that this is actually a safe product that we have developed. That's partially the first priority of us. The second priority for us is actually diminishing the EU CO2 emissions doing these drone flights. And we've developed a fairly complex algorithm to make sure that we optimize for CO2 emission minimizing. That's a bit of a wordplay there. So what we do is basically, we like to call it solving the puzzle in the sky. And yeah, I didn't come up with that, my colleague did. I'm not really proud of it, but now you know. So what is our software? I tried to put up a bit of buzzwords here that some people might understand, but I think what's most important to understand here is that we've developed this algorithm which can be inspected, and I think that's very important to understand. We integrate fluently with UTM system and drone control fleets. That means that our algorithm is fairly easy to incorporate into already existing products that's out there. Without being able to do this, an algorithm like this is very hard to work with. It can also handle different types of drones. Usually when we talk about drones, as you can see on the images, we're talking about quadcopters, but we're developing an algorithm that can also handle fixed wing, monocopters, et cetera, et cetera. It's all part of the dynamic parameters that we can set in our algorithm at runtime. And we actually develop a way that we can deconflict up to 100 drones right now in real time, instantaneously, and I think that's pretty amazing to do. Just the last couple of words. We have had a couple of people over here talking to us and asking us, so how far are we? And at the moment, we're doing simulation testing. We have a server chugging away back at the office that actually looks promising. We're in the phase of doing physical testing as well on proper drones, real drones in realistic environments where we can utilize some of the facilities we have in Denmark. We have universities that are very eager to help us. We have cities who are very eager to see this come out. So we are actually very close to developing a first product for this one here. And if you want to see some more about it, we actually have a demo running over here at our stand where you can see it working in real time on a computer nonetheless, but it is to simulate using drones. So thank you for your time.